I'd like to, first of all, thank Informatica for having us. Ronan and team, thanks so much for including us. And a special thanks to the partner engineering team. So Yogi and Avi and Nick's team put many hours in with our developers to help us build this connector that we're going to talk about today. So thank you all very much. So my name is Andrew Shikyar. I lead business development at BigML. BigML was founded in 2011 with the aim of making machine learning easier and accessible to more people. So before I get into the presentation, let's pause for a second on machine learning. There's a lot of hype around machine learning and a lot of definitions. In fact, if any of you do a web search right now, you'll quickly probably find a dozen different definitions on your first search page. I like to keep it simple and look at machine learning as a way to use machines to find insights or predictions from your data. And that's very much our focus at BigML. So I'm going to talk to you today about the Informatica connector for BigML. A little context here first. So machine learning and predictive analytics are a growing business imperative, right? So our focus at BigML is to empower more people in an organization to make data-driven decisions, right? So not just the quants in the back room or your highly trained data scientists, but your marketing analysts, your business analysts, your HR analysts, you name it. Putting predictive data in the hands of more people will enable a more efficient organization. The other thing we're seeing is an increased emphasis on predictive apps, predictive service, and programmatic machine learning. So what's a predictive app? Let me give you a quick anecdote. We have a customer, a big bank, that's using our platform to predict loan defaults. So we've worked with them to train a very sophisticated predictive model that can predict loan defaults over 4 months in advance before they happen with over 75% accuracy. That's a very powerful predictive model and a very powerful use case for predictive analytics. A predictive app, on the other hand, would actually be taking that model and making it actionable. So programmatic, automated email communications to protect potential defaulters that will help remediate their defaults. So that's very much where we're focused on making predictive apps, predictive platform and predictive apps and services. BigML is very much in the data doing space, but we're not so much in the data getting space, right? So if you have a nice structured data set, you can bring in a BigML, build powerful models, build predictive applications. We're excited to partner with Informatica on this connector because it makes it much easier to build predictive analyses from myriad customer data and to have the models brought back into the apps. So going back to that bank example, right, they need to pull data from a CRM system, accounts payable system, credit reporting systems, you name it. That's not possible without a connector. And so that's really why we're so excited about the future in working with the connector and the Informatica Cloud. So one of the nice things about machine learning is that it can really address a wide array of use cases and applications. So if you have historical data, a little vision, a little creativity, and the right platform, like BigML, you can really address just about any use case. Again, I think Informatica's ecosystem of cloud connectors and apps and the ability to blend and transform data will make this functionality even more accessible. So with this, I want to dig into the demo. OK. This may be a Windows feature. Oh, it's not seeing it. How can you tell? Oh, you can tell. OK, restart. OK, bear with me for a second as I reboot. While I reboot, are there any questions about predictive analytics, machine learning, or BigML? Even though you haven't seen the demo yet?
Maybe I will try to save you with stealing 2 minutes on a question, which is, what other industry or what other use cases do you see as kind of use cases for machine learning?
Yeah, I think I'm going to show a demo eventually, focus on customer churn. So BigML is very horizontally focused. Churn's a very low-hanging fruit machine learning use case, right? So again, the point is you want to learn from the past to predict the future. And if you have historical customer data, subscribers, what their usage patterns were, who's churned in the past, you can build a very actionable model from that relatively quickly. We're seeing use cases for resource allocation. We're doing a lot of some fascinating work with a law firm doing staffing predictions, right? It's installing updates. So you'll be happy to know I'm going to have the latest version of Windows 8.x momentarily. So we're doing staffing predictions, right? So they're taking 6 million time entries, 6 million rows of time entries to help them understand, both internally to predict what type of legal profiles we're working on a case, but also externally, so they can go to their clients and give them an estimate on how much a case is going to cost. And so we have actually, bubbled this up as a predictive application where there's a very simple interface where they could simply type in the type of law, the name of the partner, and they can get out a very simple prediction that shows, estimated hours worked by each profile of worker. But behind that, we're actually spinning up, hundreds, if not thousands, of models and ensembles that are actually doing, some very, very powerful predictive work.
Yeah, no, I think thanks for that, and I think especially for the ISV audience, churn analytics of when is the right time to upsell and what's the right thing to upsell are kind of what we live on our day-to-day. Is this a good, seems like we're almost there, right?
Hey, okay.
Perfect.
Ha. So this is I'm gonna get into the demo. Backwards. This is the end view in Salesforce. I'm gonna get into sausage making in just a second, right? So obviously, a lot of people use Salesforce, and I'm gonna show you an example how we've actually brought a predictive model into Salesforce to predict churn, and I'm going to go back and show you a different data set actually building a churn model in BigML. So you can imagine I'm here in Salesforce. I can take a look at my current subscribers. All right, so this could be one view for the sales rep, or maybe it's a customer retention rep, and I could get your standard view here on how people are consuming your content. But what we did is actually build a model and bring it into Salesforce to look at potential churners. Right, and so here you can see I've actually built this, and I've sorted it by a priority indicator and a priority. What you see here is a prediction confidence, and this is what BigML output. Right, so we built a model to predict churn, and it's a binary model. Right, so you're either going to churn it or not, and we associate a confidence with that. In this case, we associated 61% confidence that someone will churn. We brought that into Salesforce. And then the related, the priorities and the coloring is something that was generated by the Salesforce environment. All right, so how do we get there? So the first thing you got to do is actually build a predictive model in BigML. So let me show you our environment. This is our website, BigML. This is also where you access our. This is where you access our platform. I need to upload one more thing. Whoa. I'm going to show you the data set we're going to look at. Doing all this very much on the fly. Okay, so as I log into our account here at BigML, I'm going to log into my account. Our focus at BigML, as I said, is to make machine learning easier and accessible to more people. At each step of our workflow, you'll see that there's more advanced options for more advanced users and more advanced use cases, right? So this is my main account here. I've done a lot of work in BigML. I can sort this by a variety of ways. And then we also have this concept of projects here, right, where I could actually open up the Data Mania project that we've worked on for this demo, right? So at each step of the workflow, you'll see, again, more advanced options for more advanced users and more advanced use cases. Bringing data into BigML can come in a variety of ways. The data set we're going to work with is this churn data set. There's a telecommunication churn data set. So we see you have a number of fields ranging from user ID to state to account length, a bunch of quantifiable fields here, with the end field being churn. Did someone churn or not? So again, we want to train a predictive model based on this historical data. All right, so I can bring data into BigML. If I happen to have the data set on my desktop, I can simply drag it into BigML. I can also go from a web link. We've also, we sit on S3, so you can take S3 buckets into BigML quite quickly. We've done these web connectors in the past with other platforms, right? So we've connected to Azure Marketplace, Google Drive, Dropbox. In the future, this is where we're going to add the connections through the Informatica cloud. Now, I did work with a connector to actually bring the data into BigML. This is a data set that I have here, the same one as I showed you a second ago. So our first view is in the data source view. Actually, let me pause for 1 second. One thing I should mention is that as intuitive as the interface may be, it's very important to note that This is all underpinned by a full-fledged REST API that actually has more functionality and can be accessed through bindings in Python, Node, Java, and many other languages. Okay? So as I get into my example here, the first thing you'll see is I've actually flipped the table on its side. Right? So these are now my fields, and you can see I have user ID on down through churn. BigML will categorize your data into one of 4 types. So we automatically detect data and we'll assign it to numeric data, categorical data. We can handle text data and actually take free text and tokenize the text. We can also handle date data and break up a timestamp into year, date, month, hour, minute, second. So in this case, you can see, for example, the account length is a numeric field, and state, for example, is a categorical field. Now, if anything's miscategorized, which I don't like working in this view, I can simply make a change here. So area code, for example, was seen as numeric. I can update it to categorical, and just make that update here. Okay, so my next step is to build a data set. So I go to this data set view. I can, no thank you. I can Data Mania, Churn. All right, so I'm going to create a data set here. So if you have a larger data source, you might want to take a sample of it before you build your data set. In this case, I'm going to take the whole thing because it's a very small data set. This is our data set view, and this is really the foundation from which you'll do everything else in BigML. So I'm just going to show you a simple model build, but bear in mind our machine learning platform can build ensembles or random forests, anomaly detectors, and clusters. We'll be outside. If you're interested in seeing it, we'll show you how it's done. The data set view is actually quite informative in and of itself. So these histograms, for example, on account length, will show you our distribution. On the right-hand side, we have our univariate analysis. For categorical, we can see the area code split between 408, 415, and 510. If we had text, we'd actually do a text cloud around that. One other thing you could do in the dataset view is actually filter. So if I only wanted to build a model based on 415, I could do that quite easily with a couple steps here in BigML. Let's go back to the task at hand, and that's to build a model, though, to predict churn. So I simply go to Configure Model. So I skim down, you'll see that the crosshairs are on churn. That's our target variable. By default, we target the last one. If I want to pick anything else, I could just choose a different objective field. Again, as I mentioned, we have more advanced options for more advanced users. So for example, we can handle missing values. This controls the depth of the tree. If you want to weight different fields differently, you can actually do balancing and assign weights. Different types of sampling options and ordering options as well. In my case, I'm just going to keep it simple, but I do want to deselect some fields. As a marketer, I know that phone number and user ID has no predictive value. Right? So I'm going to take those fields out just by deselecting them. And then everything else looks OK. I'm going to go ahead and create my model. And so our core algorithm is decision trees. We chose decision trees on purpose for a couple of reasons. First of all, they're very easy to understand and interpret by technologists and business folks alike. Secondly, they're very easy to compound for ensembles or random forests. That's a very important and very accurate predictive methodology. So let's take a look at our tree. Our decision tree basically parses through all the data to try to come to a conclusion. Right? Our conclusions are shown as these green leaf nodes, which are solid green with a solid line around them. And each step of the tree, we're making a prediction. Right? So at the root node here, you see we have a prediction that someone will not churn with 84% confidence. On the right-hand side is a prediction path, and this tells us what field is actually being used to analyze this data. So we see total day minutes is the field that we're going to use to start parsing out the data. Now, you can see here that the size of the branch of the tree symbolizes the data flow. And we see a huge split. And I see here that if I'm actually talking over 262 minutes, all of a sudden, this individual has a 50% chance of churning, which is a big differential from the opposite, which is 87% chance of not churning. So let's go down this path a little bit. I see that the next field is voicemail plan. If this guy does not have a voicemail plan, odds are higher that they'll churn. And then total evening minutes, over 184, confidence is going even higher. And then total night minutes, if they're over 171, we now have a conclusion with 95% confidence that this individual will churn. All right, so our visualization is fully interactive. We compress the trees to fit in this space, but every tree does come to a conclusion. You can come back to this. We also have this quick filter button, which I use whenever I build a model to make sure it's decent. This is only looking at very confident patterns, so over 50% confidence in the prediction, and over 1% support, meaning that more than 1% of the data supports it. I can also filter this by outcome. Right, so if I'm trying to identify churn, this right now are the top 4 patterns for identifying churners for this telecommunications company. This is very insightful, right? So I could actually work with this in when I say an offline or analog type fashion. I could tell my customer service reps, hey, if someone dials in and they've spoken for more than 262 minutes, and they fit the rest of this criteria, please give them a free month, or send them flowers, or do something to keep them engaged as a customer. Right? But what's more interesting is the actionability of this model. When I say actionable, I mean we could actually do a number of things with it. So first of all, we can predict against it. So we have a very simple prediction interface in BigML. Again, when you look at a predictive app, you can reskin this with knobs and buttons, or it's a simple input form. But here you see, based on all the data that's already pre-input here, we have an 89% confidence of someone churning. But in real time, as I actually change the minutes, you can see the prediction changes, right? And so this is one way of actually predicting against the model, and it's a very actionable activity. Now, as I go back to the model, another thing to look at here is the machine learning model summary report. And this is very insightful. So this is a field importance view. This is the relative importance of each field in the data set and tells you its impact on the final prediction. So here we see, for example, total day minutes is 24% importance, followed by total evening minutes, and so on. So this is great insight into your data that you really can't get otherwise. And this is telling you the relative importance of each field on the accuracy of your prediction. You can imagine if you have hundreds of rows of data, or if you're in a manufacturing type process where you don't even know what the process may be, this is a really great way to find out what's impacting outcomes within your business. Last but not least, the model is fully actionable. Right? So I could actually download this model. So I could download it. We're just talking about Excel. I could actually download it in Excel if I wish. I could download that into Excel, and it actually takes the whole model and all the code associated with it. I could open that up. I could download it in Tableau. So we have a nice little Tableau extract. I could import this into Tableau as a calculated field and score my data in Tableau with this very easy-to-build model. But we also have, a lot of our people work in Python and Java. So here's a Python code, for example. All right, and so this is really more of a demonstrative thing. So this is actually I forget earlier. So earlier, someone earlier on showed a decision tree that was built in Python. This is basically the same type of code. You see, it's a big nested if-then statement. And if you wanted to modify your tree, you could actually copy and paste this in a Python shell and do that. But what's more interesting to me is the fact that this here is the model, right? This right there is the model. This model is not a Data Mania churn model. It's model 54F7A87, blah, 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 blah. And so if I'm building a predictive application, all I have to do is actually reference this model, right? This is the beauty of cloud computing. This is the beauty of cloud machine learning. So I can reference this model in my application, in my workflow, and automatically be spitting out predictive outputs based on that model. And those outputs then can be brought into my application, whether you're building a recommender system, a churn communication system, whatever it may be. This is where programmatic and actionable machine learning is quite powerful, and why the Informatica connector for BigML is a critical component to our future growth. So that's the demo, warts and all.